Students, welcome to the part B of today's class. We have been doing the semi-empirical mass formula, and we had learned what are the different terms associated with the mass formula, and now we will sum this formula up. So collecting all the terms together now of the semi-empirical mass formula, we find that the mass of a neutral atom containing Z protons and A minus Z neutrons is given by like this. You see, this is like this. You either write it this way or here, Z. So what is this? This is the mass of a neutral atom whose mass number is A and whose atomic number is Z. And this is written as how much? Since it has got Z protons, Z into mass of the proton plus A minus Z into mass of the neutron plus Z into mass of the electron, because you see, if there are Z protons, there must be Z electrons also there, minus the binding energy. So this is the formula for mass, and this is because you know that when I combine all these masses, what happens? A little bit of the mass gets converted to energy in keeping the nucleons together, and we have talked about it in our discussion on binding energy. Now, by the binding energy semi-empirical mass formula, we came to know that what is B? B is the sum of like this. It is BV plus BS plus B coulomb PC. So B volume, B surface, B coulomb plus B asymmetric. We write it like this, plus B pairing, we write as BP, plus B magic if we are talking about an element whose A or Z or N is a magic number. Otherwise, you don't need this term. So now we also learned today that what is BV? BV is AV into A. Again, this is a negative number, so this becomes AS. This is like this, AS into A to the power 2 by 3. And what about coulomb? Yes, it is also negative, so it is Z square A to the power 1 by 3. So we reach till here. Now asymmetry. Asymmetry is, this is again A N minus Z whole square, N minus Z whole square divided by A. I think I'll just rub this because you might be confused. This is N minus Z whole square. Here we have this whole square. This is the asymmetric. Then this is the asymmetric. We have done the pairing. The pairing is like this. It is plus minus AP to the power AP into A to the power 3 by 4. So these are the things, and we have the, of course, the magicity, which is plus AM into A. But then this part is not a general part of this semi-empirical mass formula. So when I use all this in place of B, the whole formula becomes this plus this plus this plus this minus this. So this becomes, its sign gets changed, and we have the total binding energy, the total formula like this. So thus the mass of the neutral atom becomes, means this was the formula, the one that we had written on the top. This was the formula for for the mass, and when I use this, then what we have is, see, it's very difficult to operate this board. Becomes M A Z is equal to Z M H. Now what is this ZMH? ZMH is the sum of ZMP and ZME. What is this? Z, mass of one proton plus mass of one electron, is mass of a hydrogen atom. So we have seen this earlier. I had explained this. If you have gone through my videos, you will understand this. Plus A minus Z M N, and then this comes like this, minus AB into A, then this one plus AS into, plus AS into A to the power 2 by 3 plus this one A coulomb into Z square by A to the power 1 by 3 plus A asymmetric n minus Z the whole square by A. It becomes minus plus AP A to the power 3 by 4, neglecting the magicity term. So this is the whole semi-empirical mass formula. So if you asked about the semi-empirical mass formula, you have to do this one, and then let's move on to newer things. So let us at the end look at the values of what are AV, AS, AC and AA, AS. You'll find that AV is equal to 15.29. See, these results have been found purely by experimenting, and there are no theories involved here. This is A surface is AV. A surface is 15.76, A coulomb is 0.69, A asymmetric is 22.63. So these are the different values. Now let us move on to do something else called the nuclear models. So what are nuclear models? Nuclear models. Students, you must have seen one thing that in atoms we have atomic models. What are the atomic models? What are models actually? These are just a idea or a formula or some kind of theory of how things which we don't know, which we cannot see with the eyes, can be. Just like the atom, since it cannot be seen, so people had to think what is the shape, how is, and so on. So in case of atom, the model was the Thomson's model. Then came the Rutherford model. So I will not go through this. This will come in the first part of your syllabus, which will be taught by some other faculty. And the Bose atomic model, and we still follow the Bose atomic model. So Bose model. So you see, little by little things develop and we come to models like this. Similarly for nucleus also we have a certain models. And in case of nuclear models, in your syllabus you only have the liquid drop model. So just to inform you, there are other models called the Fermi gas model, the Fermi gas model, which developed very early. So nuclear models, we have the Fermi gas model. Then we have the liquid drop model, which could explain so many things. So many nuclear phenomenon. And then came the shell model, which is the most advanced model, shell model. So just to tell you, just to inform you, just to give you some idea, shell model is that particular model in which it is just like the atom. In atom, you know, you have a nucleus at the center, and then you have certain shells where you have n is equal to 1, n is equal to 2, and we know that the electrons are revolving around the nucleus in these orbits, and this is the Bose model. So on the same kind of idea, using the same kind of idea as the Bose model, the shell model also developed, and this shell model is quite useful for certain things, but it's highly mathematical and it's not in a syllabus. So it's enough for us to know that shell model is just like the Bose atomic model. So nuclear models means they are just trying to find out that yes, inside the nucleus we have protons and neutrons, but how are they placed? What are the types of forces? We know that they are very strongly bound to each other. They are attracted by strong force, and we have learned what the nature of the forces are, but still so many things are to be found out. So the liquid drop model, it is fairly simple, and fortunately you don't have the mathematical part of this drop method of the liquid drop model. So liquid drop model, in the liquid drop model, it was assumed that assumption was that a nucleus is just like a drop of liquid. So nucleus is just like, you don't have to write this because I'll share the notes with you, it's like a drop of liquid. So basing on this, in our next class we will be learning what is the liquid drop model of the nucleus. So I think I'll stop my class here. I hope you are listening to my videos. It will help you, and download them and keep, because after some days